Question 1. In a modern context of deploying microservices on Oracle Kubernetes Engine, OKPRI observes intermittent failures between services when one dependency experiences latency spikes. Which architectural approach best addresses this without impacting other services? A. Implement a single retry loop across all microservices. B. Use a bulkhead pattern to isolate service resources. C. Scale all dependent services horizontally. D. Route requests through a shared message queue. Answer. Correct answer. B. Explanation. Isolating service resources using the bulkhead pattern prevents one failing component from cascading failures across other microservices. A single retry loop may increase load during latency, worsening the issue. Scaling all services horizontally is reactive and may waste resources. A shared message queue can decouple services but doesn't address resource isolation, which is the primary resilience mechanism needed here. Question 2. When analyzing security practices for OSI functions, AMAD needs to store sensitive API keys without embedding them in the source code. Which OSI service should be integrated for this purpose? A. OSI Vault. B. OSI Secrets Manager within IAM. C. Environment Variables in FM Project. D. Object Storage with Restricted Access. Answer. Correct answer. A. Explanation. OSI Vault provides secure encrypted storage for API keys and secrets, ensuring centralized control and auditability. Using IAM's policy system alone doesn't store secrets securely. Environment variables can be exposed during deployment or logs. Object storage, even with restrictions, is not designed for managing sensitive runtime credentials securely. Question 3. Given the circumstances, a DevOps engineer notices that a SICK deployment to Oak caused downtime for end users. To reduce this risk, which deployment strategy should be applied? A. Roll-in upgrade. B. Blue-green deployment. C. All-at-once replacement. D. Manual image swap in OSI. Answer. Correct answer. C. Explanation. Rolling upgrades replace pods gradually, minimizing downtime but not eliminating it. Blue-green deployment ensures complete environment separation, allowing instant rollback if needed, which greatly reduces end-user impact. All-at-once replacement is risky and can cause downtime. Manual image swaps in OSI are uncoordinated and prone to human error. Question 4. By comparing Oracle functions with traditional server-based applications, Alina wants to optimize costs for workloads that run unpredictably. Which approach best fits this requirement? A. Deploy workloads on long-running compute instances. B. Use OSI functions for event-driven execution. C. Deploy workloads in containers on always-on open nodes. D. Use block volumes with compute for faster startup. Answer. Correct answer. B. Explanation. Event-driven serverless functions only consume resources when executed, making them cost-effective for sporadic workloads. Long-running compute instances and always-on oak nodes incur charges continuously. Block volumes help with storage performance but don't address the unpredictability and cost efficiency requirements. Question 5. In contrast to traditional monolithic applications, Jamal's microservices require secure service-to-service communication over private networks. Which OSI feature most directly supports this requirement? A. Public load balancer with TLS termination. B. OSI service gateway. C. VCN peering between compartments. D. Private load balancer with MTS. Answer. Correct answer. D. Explanation. A private load balancer with mutually LS ensures encryption and authentication between internal services. Public load balancers expose unnecessary attack surfaces. Service gateway connects to OSI services without public IPs but doesn't handle mutual authentication. VCN peering allows connectivity but not encrypted identity verification between microservices. Question 6. From a practical standpoint, Naomi is designing a multi-region OSI architecture prioritizing availability over consistency for a global chat application. Which CAP theorem trade-off does this represent? A. Consistency and partition tolerance. B. Availability and consistency. C. Availability and partition tolerance. D. Latency and availability. Answer. Correct answer. C. Explanation. Choosing availability and partition tolerance means the system remains operational during network partitions, potentially sacrificing strict consistency. Common choice for real-time chat: consistency and partition tolerance would sacrifice availability during outages. Availability and consistency can't be achieved simultaneously under network partitions. Latency trade-offs are separate from CAP considerations. Question 7. Under the assumption that a team uses a API gateway to expose internal IPs, they want to protect them from excessive client requests. Which configuration is most appropriate? A. Implementing a rate-limiting policy at API gateway. B. Configuring OSI-WAF for the API gateway endpoint. C. Adding retries with exponential backoff in clients. D. Using a private subnet for the API gateway. Answer. Correct answer: A. Explanation. Rate-limiting policies at API gateway enforce request thresholds, protecting backend services from overload. WAF adds security against malicious payloads, not request volume. Client retries increase load if not controlled. A private subnet restricts access but doesn't manage traffic rates for allowed clients. Question 8. The underlying principle of OSI streaming is leveraged by Ravi's application to process device data in near real time. Which practice ensures high availability and fault tolerance in this scenario? A. Using single partition per topic for simplicity. B. Configuring multiple partitions with replication. C. Processing data in batches to reduce API calls. D. Storing data in object storage before streaming. Answer. Correct answer: B. Explanation. Multiple partitions with replication distribute load and provide fault tolerance, allowing consumers to continue even if a node fails. A single partition limits throughput and resilience. Batch processing may improve efficiency but can increase latency. Pre-storing data in object storage delays processing and undermines real-time requirements. Question 9. While examining OSI Resource Manager for infrastructure automation, Carlos wants to ensure deployments can be rolled back if a change fails. Which approach best supports this? A. Use Terraform's state management with version control. B. Keep manual configuration notes. C. Apply changes directly via OSI console. D. Schedule downtime during deployments. Answer. Correct answer: A. Explanation. Terraform's state management enables versioned infrastructure definitions, making rollback possible. Manual notes lack automation and accuracy. Direct console changes bypass code tracking and are error-prone. Downtime scheduling is mitigation, not rollback strategy. Question 10. Through careful analysis of OSI logging, Sophia identifies a spike in error logs from a specific function. To improve troubleshooting efficiency, what should she configure? A. Create a metric filter to trigger alerts on log patterns. B. Archive all logs to object storage. C. Delete old logs to save space. D. Use FFX to redeploy the function immediately. Answer. Correct answer: D. Explanation. Creating a metric filter allows real-time detection and alerting when specific log patterns occur, enabling faster response. Archiving logs is for compliance, not immediate detection. Deleting logs removes valuable forensic data. Redeploying immediately without analysis risks reintroducing the issue. Question 11. In the absence of predefined capacity planning, Liam notices sudden compute instance exhaustion in OSI due to unpredictable workloads. Which approach best ensures scalability without manual intervention? A. Configure OSI auto-scaling policies on instance pools. B. Over-provision compute instances to maximum capacity. C. Migrate workloads to smaller instances. D. Schedule workloads to run sequentially. Answer. Correct answer: A. Explanation. Auto-scaling policies dynamically adjust compute capacity based on demand, avoiding manual intervention. Over-provisioning wastes resources and increases cost. Using smaller instances can worsen performance under load. Scheduling sequential execution reduces concurrency and responsiveness, undermining performance goals. Question 12. When presented with a requirement to modernize a legacy batch processing app for OSI, Sophia wants minimal code change while improving scalability. Which approach is most suitable? A. Rebuild the application into microservices from scratch. B. Lift and shift to OSI compute, then introduce auto-scaling. C. Deploy as OSI functions for event-driven execution. D. Rewrite in a containerized architecture on Oak. Answer. Correct answer. B. Explanation. Lifting and shifting to compute with auto-scaling allows quick migration with minimal code change while improving scalability. Full microservice rebuilds and containerization require major refactoring. OSI functions are best for stateless event-driven tasks, not complex batch processes without redesign. Question 13. Based on the information from testing pipelines, Kai observes that his OSI DevOps SICT process frequently fails in the staging environment due to API throttling. What is the optimal solution? A. Increase pipeline concurrency. B. Implement retry logic with exponential backoff. C. Remove staging environment checks. D. Use larger compute shapes for the build runners. Answer. Correct answer. B. Explanation. Exponential backoff in retry logic prevents hitting API emits by spacing out retries, mitigating throttling issues. Increasing concurrency worsens throttling. Skipping staging removes essential quality gates. Larger compute shapes improve processing speed but not API rate limits. Question 14. Demonstrated by real-time analytics systems, Maya needs to process continuous clickstream data from a global e-commerce site, which OSI service combination best addresses low latency ingestion and processing. A. OSI streaming with functions for event handling. B. Object storage with batch data imports. C. Autonomous data warehouse with nightly ETL jobs. D. File storage with scheduled scripts. Answer. Correct answer. A. Explanation. OSI streaming provides low latency ingestion and event handling when paired with functions for immediate processing. Object storage and nightly ETL jobs are unsuitable for real-time needs. File storage with scheduled scripts introduces unnecessary latency and lacks scalability for continuous streams. Question 15. From multiple perspectives, ROD's containerized application experiences performance degradation when multiple services write large files to shared storage. Which approach is most effective? A. Increase block volume size for more throughput. B. Migrate shared file operations to object storage. C. Use OSI file storage with parallel EO tuning. D. Cache data in memory before writing to disk. Answer. Correct answer. C. Explanation. OSI file storage with optimized parallel EO tuning handles concurrent large file writes efficiently. Increasing block volume size helps only individual volumes. Object storage isn't ideal for frequent file writes due to eventual consistency. Memory caching improves read-write speed but doesn't solve shared EO contention. Question 16. In response to compliance requirements, Zoe needs to ensure all data at rest in OSI object storage is encrypted with her own keys. Which solution satisfies this? A. Enable Oracle-managed encryption. B. Use customer-managed keys in OSI Vault. C. Store keys locally on application servers. D. Implement software-based encryption in code only. Answer. Correct answer. B. Explanation. Customer-managed keys in OSI Vault give Zoe control over encryption and key lifecycle management. Oracle-managed encryption doesn't allow custom key control. Local server key storage risks compromise. Software and encryption adds complexity and lacks centralized security integration with OSI services. Question 17. By evaluating message processing architectures, Ethan seeks to decouple order placement from order fulfillment for better scalability, which OSI service best supports this. A. OSI events. B. OSI streaming. C. Web API gateway. D. OSI service connector hub. Answer. Correct answer. B. Explanation. OSI streaming provides a durable, scalable event log enabling decoupled asynchronous processing between services. OSI events is better for reacting to resource state changes. The API gateway handles synchronous requests, not decoupling. Service connector hub routes data flows, but is not the main event queue. Question 18. When faced with the need to integrate OSI functions with external APIs requiring OAuth authentication, Marcus wants to avoid re-authenticating on every call. What's the most secure and efficient approach today? Store and reuse tokens in OSI Vault. B. Embed tokens in environment variables. C. Hardcode tokens in the source code. D. Request tokens on every function execution. Answer. Correct answer. A. Explanation. Storing tokens securely in OSI Vault allows reuse without hard-coding or exposing them, ensuring security and efficiency. Environment variables can be exposed in logs. Hard-coding tokens is insecure. Requesting tokens on every execution wastes resources and may hit API rate limits. Question 19. Through the lens of API performance monitoring, Aisha finds that backend services sometimes exceed the API gateway timeout limit. How should she handle long-running requests? A. Increase API gateway timeout to maximum. B. Offload to asynchronous processing and return status links. C. Split requests into multiple smaller synchronous calls. D. Use a load balancer to bypass the API gateway. Answer. Correct answer. B. Explanation. Asynchronous processing avoids timeouts by returning a status link, letting clients check results later. Simply increasing timeouts may cause resource lockups. Splitting into smaller calls works only if tasks are naturally divisible. Bypassing API gateway removes its benefits like security and rate limiting. Question 20. Considering the evidence, Daniel's team uses OSI Resource Manager for infrastructure automation but struggles with repeatable environment setups. Which practice ensures consistency? A. Store Terraform configurations in version control. B. Apply manual changes post-deployment. C. Clone existing environments manually. D. Use OSI console to replicate resources. Answer. Correct answer. A. Explanation. Storing Terraform configurations in version control ensures that infrastructure changes are tracked, repeatable, and auditable. Manual changes undermine consistency. Cloning manually risks configuration drift. Console replication lacks automation and version history, making it prone to errors. Question 21. When considering the design of a high-throughput data ingestion pipeline on OSI, Maria wants to ensure minimal data loss in case of a node failure. Which configuration is most appropriate? A. Multiple partitions with replication enabled in OSI streaming. B. Single partition with high-capacity storage. C. Scheduled batch uploads to object storage. D. Direct writes to autonomous database tables. Answer. Correct answer. A. Explanation. Multiple partitions with replication ensure both scalability and durability, preventing data loss during node failures. A single partition limits throughput and resilience. Batch uploads to object storage increase latency and risk losing in-flight data. Direct writes to a database bypass event buffering and can overload the DB during spikes. Question 22. In contrast to traditional logging setups, Jack wants real-time alerting when error rates spike in OSI functions. Which practice best supports this? A. Create a metric filter in OSI logging and link it to an alarm and monitoring. B. Export logs daily to object storage for analysis. C. Manually review logs in the console. D. Increase function memory allocation. Answer. Correct answer. A. Explanation. Metric filters tied to alarms enable near-instant notifications, improving incident response. Exporting logs daily delays detection. Manual review is reactive and time-consuming. Increasing memory allocation may improve performance but doesn't provide detection or alerting. Question 23. Throughout the course of migrating a monolithic application to OSI microservices, HANA must ensure services can authenticate without exposing credentials. Which solution aligns with OSI best practices? A. Store service credentials in OSI Vault and access via dynamic groups. B. Embed credentials in application containers. C. Share credentials via email with the team. D. Use plaintext config files in object storage. Answer. Correct answer. A. Explanation. OSI Vault with dynamic groups allows secure programmatic access to secrets without embedding them in code or containers. Email and plaintext configs are insecure. Storing credentials inside containers risks exposure if images are compromised. Question 24. With respect to scaling containerized apps on Oak, Alex finds that auto-scaling events cause brief downtime due to pod initialization delays. Which strategy best mitigates this? A. Use pod pre-warming with readiness probes configured. B. Reduce pod resource requests to speed scheduling. C. Disable auto-scaling to maintain steady state. D. Schedule deployments during low traffic hours. Answer. Correct answer. A. Explanation. Pod pre-warming combined with readiness probes ensures new pods are ready before traffic is sent, reducing downtime. Lowering resource requests may lead to performance issues. Disabling auto-scaling removes scalability benefits. Scheduling during low traffic minimizes impact, but doesn't solve the readiness delay. Question 25. In a modern context of securing APIs with OAPI Gateway, Olivia needs to restrict access to only clients with LDW issued by an external identity provider. Which configuration achieves this? A. Configure a delegation policy at API Gateway. B. Use an IP whitelist in the vSyn. C. Add client IP checks in application code. D. Restrict to a private subnet only. Answer. Correct answer. A. Explanation to delegation policies at API Gateway enforce token-based authentication at the gateway level. IP whitelists and subnets control network access but not identity. Application-level IP checks are less efficient and harder to maintain than centralized token validation. Question 26. From a historical standpoint, Lucas wants to implement a deployment strategy in OSI DevOps that allows gradual traffic shifting to new versions while monitoring for errors. Which approach is best? A. Canary deployment. B. Blue-green deployment. C. Roll-in restart. D. All-at-once deployment. Answer. Correct answer. A. Explanation. Canary deployment shifts a small portion of traffic to the new version first, allowing our monitoring before full rollout. Blue-green swaps environments entirely, but doesn't provide gradual exposure. Rolling restarts work for containers, but may not monitor live traffic in phases. All-at-once offers no safety net. Question 27. The most significant aspect of OSI's Service Connector Hub is its ability to route data between services like logging, streaming, and object storage without custom code. B. Act as VPN tunnel between ECE and S. C. Replace all API gateway functionality. D. Serve as replacement for Terraform in infrastructure automation. Answer. Correct answer. A. Explanation. Service Connector Hub automates data movement between OSI services with minimal coding. It does not handle networking tunnels, API gateway roles, or infrastructure automation like Terraform. Question 20. Given the circumstances, Chloe needs to ensure that container images stored in OSI are scanned for vulnerabilities before deployment. What is the correct practice? A. Enable OSI vulnerability scanning service on repositories. B. Scan images only after deployment. C. Store images in public repositories for community review. D. Manually download and scan images locally. Answer. Correct answer. A. Explanation. Enabling OSI's vulnerability scanning automates security checks before images are deployed. Scanning post-deployment risks running vulnerable software. Public repos risk exposing proprietary code. Manual local scans are less consistent and harder to enforce across teams. Question 29. The prevailing attitude toward event-driven architecture is that it can improve responsiveness. No's team wants to trigger automated scaling of compute pool when an object is uploaded. Which OSI service combination is most effective? A. OSI events plus functions. B. OSI streaming plus autonomous database. C. Object storage plus manual scaling. D. API gateway plus load balancer. Answer. Correct answer. A. Explanation. OSI events can detect object upload events and trigger functions, which in turn can automate scaling actions. Streaming is for continuous data. ingestion, not simple file-triggered automation. Manual scaling is inefficient. API gateway and load balancer don't react to object storage events. Question 30. In light of recent developments, Victoria needs to ensure sensitive customer data stored in object storage is encrypted in transit. Which approach is correct? A. In an ATLF for all object storage requests. B. Use only Oracle managed encryption keys. C. Disable public endpoints entirely. D. Compress data before uploading. Answer. Correct answer. A. Explanation ATS ensures encryption in transit between clients and object storage. Oracle managed keys protect data at rest, not in transit. Disabling public endpoints restricts access but doesn't guarantee encryption. Compression improves efficiency, not security during transmission.